This topic is about the equation of a circle in context. We will be looking at finding the center and radius of a circle from the fully expanded form. We also need to be able to find points of intersections of a circle with axes or a line. I will go through concepts and examples. Feel free to pause whenever you want. Okay, firstly, as a reminder, I need to go through the equation of a circle formula. So if you have a circle with center AB and radius R, so AB is equal to center and R is equal to radius, then the equation of a circle is equal to x minus a squared plus y minus b squared is equal to r squared. So remember, it's equal to r squared, okay? So because a lot of people get it wrong and they think it's equal to r. It's equal to r squared. Okay, so let's go through some examples now. The first example, so here we have a fully expanded form of an equation of a circle, and we need to find the center and radius of the circle with each of the following equations. Okay, so we need to get into the correct form. So first thing I do is get all the x's together, x squared minus 2x, put all the y's together, y squared plus 4y, take away 7 is equal to 0. Okay, now I need to complete the square because I need to get into the correct format. Remember, the format is like this. So we need to get into that format. Okay, so if I complete the square, remember I half the coefficient of x and I take away the square of that. And do the same thing with y, so half the coefficient of y, take off the square, and then don't forget about the take away 7 is equal to 0. Okay, if I clean this up, I get x take away 1 squared plus y plus 2 squared. Negative 1 take away 4 take away 7 gives me negative 12 is equal to 0. I need to take the 12 over to the other side, so I end up getting x minus 1 squared plus y plus 2 squared take away 12, is equal to 12. Okay, which implies the center is equal to 1, negative 2, and the radius is equal to the square root of 12. Remember, the right hand side is r squared, so r is equal to square root of 12. Okay, let's do B. Okay, again, collect all the x's together. So I've got, first, with the second example, let's get everything to one side and leave the constant on the right hand side. So if I take the 2y to the left hand side, I get x squared plus 6x plus y squared, take away 2y, leave the 15 on the other side, okay? Because obviously we want r squared, the constant on the right hand side anyway, so just leave it there. Okay, complete the square with the x, I get x plus 3 squared, take away 9, plus y, take away 1 squared, take away 1, is equal to 15. Okay, I need to collect the constants together. So I get x plus 3 squared, plus y minus 1 squared, take away 10 is equal to 15. Take the minus 10 over to the other side, so I get x plus 3 squared plus y minus 1 squared is equal to 25. Got in the correct format now, so the center is equal to negative 3, 1, and the radius is root of 25, which is equal to 5. Okay, let's do C now. Okay, collect all the x's together, so I've got x squared plus 5x plus y squared, take away 3y, minus 8 is equal to 0. Complete the square, so I get x plus 5 over 2 squared, take away 25 over 4, plus y, take away 3 over 2 squared, minus 9 over 4, take away 8 is equal to 0. Okay, if I rearrange it, I get x plus 5 over 2 squared plus y minus 3 over 2 squared minus 25 over 4, take away 9 over 4, gives me minus 34 over 4. Minus 8 can be written as minus 32 over 4 is equal to 0. If I combine these together, I get minus 66 over 4, which is equal to minus 33 over, if I half it, minus 33 over 2. Okay, which means I can rewrite it as x plus 5 over 2 squared plus y minus 3 over 2 squared is equal to 33 over 2. Okay, which implies the center must be equal to negative 5 over 2, positive 3 over 2, and the radius is square root of 33 over 2. If you want to write it much nicer, you can write it as square root of 66 over 2. Okay, the last one, which is d now. D, okay, we've got 2x squared, take away 8x, plus 2y squared, plus 8y, plus 3 equals 0. Okay, I need to divide through by 2 in order to get rid of the coefficients in front of x squared and y squared. So I get x squared, take away 4x, plus y squared, plus 4y, plus 3 over 2 is equal to 0. Okay, complete the square now. So I get x minus 2 squared, take away 4, plus y, plus 2 squared, take away 4, plus 3 over 2 equals 0. Okay, let's put in the correct format. X minus 2 squared plus y plus 2 squared minus 4 gives me minus 8. Minus 8 plus 3 over 2 is minus 8 plus 1.5, which gives me minus 6.5. So that's negative 13 over 2, which is equal to 0. Okay, x minus 2 squared plus y plus 2 squared is equal to 13 over 2, which implies my center must be equal to 2, negative 2, and my radius must be equal to square root of 13 over 2, which can be written as square root of 26 over 2. Okay, the next example now. So the point P22, Q2 plus root 3, 5, and R2 minus root 3, 5 lie on the circle x minus 2 squared plus y minus 4 squared is equal to r squared. Find the value of r. Okay, so let's do a rough sketch. So because my circle has center 2, 4, and radius r from here, so center is equal to 2, 4, and radius is equal to r, because we don't know what it is. And somewhere here we've got P, which is equal to 2, 2. Somewhere on the circumference of the circle we've got Q, which is equal to 2 plus root 3, 5. And another point R, which is equal to 2 minus root 3, 5. So let's find the value of R. Okay, so if you want to find the radius, the easiest way to find the radius is find the distance between the center and P. The center and P, which is the square root of 2 minus 2 squared plus 4 minus 2 squared, which is the square root of 2 squared, which is equal to 2. Okay, so the radius is equal to 2. So that was part A. B, it says show that the triangle PQR is equilateral. So if we draw a triangle, if it's equilateral, all 3 sides must be of the same length. So all I need to do is work out the length of each one and show that they're the same. Okay, distance between P to Q. Okay, so changing x squared, so 2 plus root 3 minus 2 squared plus 5 minus 2 squared, which gives me root of 3 squared, which is 3, 5 minus 2, which is 3 squared, which is 9, which is root of 12. Okay, let's work out the distance between P to R now. So P to R now, same thing, changing x squared, so 2 minus root 3 minus 2 squared, plus changing y squared, 5 minus 2 squared, which gives me negative root of 3 squared, which is 3, plus 5 minus 2 squared, which is 9, which is root 12. Okay, now I need to work out distance between Q and R. Okay, so difference between x squared, so it's 2 minus root 3, take away 2, take away root 3 squared, plus 5, take away 5 squared, root, changing y squared. Okay, so you end up getting here negative 2 root 3 all squared plus 0 squared, which gives you root of 12. So since the distance between P to Q is equal to the distance between P to R, which is equal to the distance between Q to R, which is equal to root 12, the triangle PQR is equilateral. Okay, the next question. A circle C has equation x squared plus y squared plus 12x plus 12y is equal to k, where k is a constant. Find the coordinates of the center C. Okay, I need to obviously get in the correct form. So collect all your x's together. Collect all your y's together. Leave the k on the other side. Okay, complete the square for x. So I get x plus half of 12, which is k squared. Take away 6 squared, which is 36. Complete the square for y now. So half 2, which is 1. Take away 1 squared, which is 1, is equal to k. Okay, x plus 6 squared plus y plus 1 squared. Take away 37 is equal to k. Take this negative 37 to the other side, so you end up getting x plus 6 squared plus y plus 1 squared is equal to k plus 37, which implies the center is equal to negative 6, negative 1. B. State the range of possible values of k. Now, we do know in the equation of a circle, radius is greater than 0. Now, if the radius is greater than 0, then when we do radius squared, that must also be greater than 0. Which implies our radius squared here, this is radius squared, our k plus 37 must be greater than 0. Which means k must be greater than negative 37. And that will be your range of possible values of k. The circle with equation x minus k squared plus y squared is equal to 41 passes through the point 3, 4. Find the two possible values of k. Now, if the equation passes through the point 3, 4, it must satisfy that equation. So we need to substitute 3, 4 into x minus k squared plus y squared is equal to 41. So when we substitute in, I end up getting 3 minus k squared plus 4 squared is equal to 41. Okay, so if I expand the 3 minus k squared, I get 9 take away 6k plus k squared plus 4 squared is 16 is equal to 41. Okay, k squared take away 6k, 16 plus 9 is 25, so plus 25 is equal to 41. It's a quadratic in front of me, so I need to take the 41 to the left-hand side to make the right-hand side equal to 0. So I get k squared take away 6k, 25 take away 41 gives me negative 16 is equal to 0. I need to factorize it. This looks like it's going to factorize. So I want two numbers that multiply to give you negative 16, add to give you minus 6. That works out to be negative 8 plus 2, which means k plus 2 equals 0, or k minus 8 is equal to 0, which implies k is equal to negative 2, or k is equal to 8. So those are my two possible values of k. Okay, let's go on to the next example. By completing the square, find the center and radius of the equation x squared plus y squared plus 2fx plus 2gy plus c is equal to 0. So let's first collect the x's together. So I've got x squared plus 2fx. Collect the y's together. So y squared plus 2gy plus c equals 0. Okay, complete the square on the x. So when we're completing the square, remember we half the coefficient of x, so half of 2f is f. Take away the square of that, which is f squared, plus y plus half of 2g is g. Take away g squared plus c is equal to 0. Okay, now if I collect all the constant together, I get x plus f squared plus y plus g squared. If I take all the constants to the other side, I get positive f squared, positive g squared, take away c. Okay, now that I've got in the correct format, my center is equal to negative f, negative g. And my radius is the square root of f squared plus g squared, take away c. Okay, next example now. Prove that the circle x plus 4 squared plus y minus 5 squared is equal to 82 lies completely inside the circle x squared plus y squared, take away 8x, take away 10y is equal to 51. Okay, so let's call this one circle 1 and let's call this one circle 2. Okay, so let's look at circle 1 first. So because we've got x plus 4 squared plus y minus 5 squared is equal to 82, the center is equal to negative 4, 5, and the radius is equal to root 82. So if I draw a rough circle, so my center is negative 4, 5, and my radius is root 82, and this is my circle 1. Okay, now if I look at circle 2, which is equal to x squared plus y squared plus 8x minus 10y is equal to 59. Let's collect all the x's together and the y's together. Then if I complete the square, I get x plus 4 squared take away 16 plus y take away 5 squared take away 25 is equal to 59, which means I get x plus 4 squared plus y minus 5 squared take away 41 is equal to 59. X plus 4 squared plus y minus 5 squared is equal to 59 plus 41, which is equal to 100. Which means in the center is minus 4, 5. And the radius is square root of 100, which is 10. The circle, so C2, the center is the same, but the radius is 10, which is bigger than root 82. So this is C2, you can clearly see, and C2 has radius 10, you can clearly see C1 lies completely inside the C2. So I would write an explanation. Since C1 and C2 share the same center, but the radius of C2 is greater than the radius of C1, C1 must lie completely inside C2. As long as you write an explanation, you'd get full marks in an exam.